This is a small unit that we recently built to demonstrate how a reverse osmosis unit performs. The unit here is quite small, of course. It would purify about 100 gallons of water a day, and this type of unit is designed to perform on municipal waters or many well water applications. The same process with slightly different components can be used to turn seawater into good quality drinking water. So what we're going to do is run it in a few minutes. The water will be drawn through this orange tube into a particle filter here. That takes out any, I call it chunks, or any visible pieces of material that are in the water. And within this chamber is nothing more than something like a cotton sock that is woven quite tight. Then the water leaves here and it goes upflow through this particular filter. We use a clear one so you can see what's in it. The first thing that the water sees is a material called KDF. And KDF will take the chlorine out of the water, reduce the chloramines, and take out many of the heavy metals. Then the water continues up through this bed, which is a very special grade of activated carbon. And its job is to take out any remaining chloramines. And that chloramine process is quite important, especially if you're going to use this kind of process for dialysis equipment, because the chloramines become quite toxic to the patient. Then the water comes out of here, goes into a pressurizing pump, comes out of the pump, and goes through the reverse osmosis membrane. I have a sample of a membrane here that I simply cut in half so that you can see it's many wound pieces of plastic through which the water flows. And I've also totally taken one apart so you can get a better idea of the fact that it's a rolled piece of plastic with some spacers in it. So with that in mind, let me start. Incidentally, the RO membrane has a porosity such that the pores are so small that it'll take out any of the bacteria or viruses that are in the water, and will also take out any cysts, such as the cysts that arise quite often in the Great Lakes area. So with that, let's plug it in and make it work for its living. I'm going to put the suction tube, and we've got food dye in here, so you can see it's kind of an icky looking water because of the dye. And very shortly we'll be drawing it out, and we'll see the water flow coming through here or down through here, and we'll be able to visualize it going upward. You can see a little movement in the bottom here indicating it's starting. We're just building up pressure now. I want to control it. There you can see the red at the bottom of this filter. Now we're starting two processes. One is the good water coming out of the blue line, or the RO water, and the other will be a much darker version of the red water going to drain, indicating that we are separating the water from the food dye. And we should have something available here in just a few seconds. I can see we're making product water at a pretty good rate over here. So again, we're taking the colored water and the color is an organic compound that comes out, and you can see that the drain water here is picking up the color, and the product water, good water, is perfectly clear. So that's just a simple explanation and a demonstration of how reverse osmosis works. It's going to be very important in our future, especially here in California, where we're running out of fresh water. We're in the desert, and taking seawater through essentially the same process and producing a nice quality water is going to be very important to human growth here in California.